Hello everyone. In this video, we will continue with the previous one to approximate the present value of annuities under different mode of payment. And here we will use the Woolhouse formula for the approximation. Using the Woolhouse formula, we don't need the UDD assumption. And the formula is given in the FAM exam. This is a three-term Woolhouse formula. And this applies to the whole life annuity deal. If you are asked to use the two-term formula to do the approximation, you simply just extract the first two terms and you get the two-term Woolhouse formula. For the three-term formula, you might need to approximate mu x if it is not given in the question. The approximation is negative 1/2 times the lateral log of px minus 1 plus lateral log of px. Simplify the expression, this equals to negative 1/2 times the lateral log of 2px minus 1. Apply this to the continuous case. For continuous annuity, we simply take m approach infinity. So the two-term formula, the two-term Woolhouse formula, as m approach infinity, the second term becomes 1/2. And the three-term, as m approach infinity, the last term, we have the coefficient 1/12. And similar for the discrete case, you might need to approximate mu x, the same approximation formula. All right, we have done with the whole life annuity deal. How about the N-year temporary annuity deal? We simply use the Woolhouse formula to do the approximation for a double dot x and a double dot x plus n for the nth case. The first term, this simply is the three-term Woolhouse formula given here. And then the second term apply to a double dot x plus n. So we simply change x to x plus n. A double dot x and mu x is replaced with a double dot x plus n and mu x plus n. Simplify the expression. All right, group the first term, a double dot x, and the first term in the second expression, nex a double dot x plus n. And then the second term in the two expression, and then the last term. The first term in the bracket, this simply is the N-year temporary annuity deal with annual payment, a double dot x colon angle n, and then the rest of the expression remains unchanged. And this is the three-term Woolhouse formula for the nth N-year temporary annuity deal. For the N-year deferred annuity, applies the three-term Woolhouse formula for a double dot x plus n, the nth case. And then the first term, nex a double dot x plus n, is simply the N-year deferred annuity deal at hx. And then the second term, the third term, remains unchanged. Again, there's no need to memorize the formula. You are given the formula for the whole life annuity deal, and then you can see the similarity. The first term is always the corresponding annuity with annual payment. And then the second term, for the n-year annuity due, this multiplies by 1 minus NEX. And for the n-year deferred annuity due, the second term is multiplied by NEX. The last term, we have similar relationship. We have delta plus mu x, and then delta plus mu x plus n, and then multiply NEX for the last term here. And then for the deferred annuity, multiply NEX with the term delta, and then plus mu for the n-year deferred case, mu x plus n. And then for the continuous case, take m approach infinity. For the n-year temporary continuous annuity, we get this expression, just replace, just approximate, okay, take m approach infinity, and then we get this expression. And then we have the deferred continuous annuity, we get this expression. These are the approximation formula using the three-term Woolhouse formula. And then if you are asked to use the two-term Woolhouse formula, just extract the first two terms of this expression. And then I will have one example at the end of the video using the two-term formula. All right, not to forget that mu x is approximated by this expression. Okay, let's take a look at an illustration. We want to calculate this annuity due using the three-term Woolhouse approximation. All right, we have a double dot x, x is 65, 13.5498, and then m is 12. The interest rate is 0.05, so we get delta lateral log of 1.05. And then we need the value for mu 65. The approximation for mu x. We can make use of the QX columns to get P64 and P65. And then we can get the approximated value for mu 65. Or we can use the LX column. Here we calculate TP 2P64, which equals to L66 over L64. And we should get similar results. Plug either one of these values into the expression for mu 65, and then we get the approximation, 13.087. Another example, given the following life table, and you're given the value for A.22, A.28, and the interest rate is 6%. Calculate the 6-year deferred continuous annuity at age 22 using the three-term Woolhouse approximation. All right, make use of the relationship. So we get 6E22 times A bar 28. We can get 6E22 with nu to the power 6, and then we can get L28 over L22 from the table. And we'll use the three-term Woolhouse formula to approximate A bar 28. A bar 28 equals, or approximate, equals to A double dot 28. And then as m approach infinity, the second term is 1/2, and then the last term is 1 over 12, and then times delta plus mu x. Delta is the lateral log of 1.06, and then we need to approximate mu 28. All right, so here mu 28, negative 1/2, and then times the lateral of P27 plus the lateral of P28. And this can be simplified to the lateral log of L29 over L27. And we can get these two quantities from the table. We get mu 28, and then we can get A bar 28. Substitute into the very first expression, and then we get the answer, 8.9076. The next example, you are given the present value of a whole life insurance A40, 0.415, A60, 0.753, and the survival probability 20p40 is 0.345. The interest rate 6%. And you are asked to calculate the annuity payment, M equals 2, for a 20-year temporary annuity immediate at age 40, using the two-term Woolhouse approximation. All right, get the relationship, and then apply the two-term Woolhouse formula for A double dot x and A double dot x plus n. A double dot 40 with bracket 2. The two-term Woolhouse formula, A double dot 40, and then minus the second term with m equals 2. We need the value for A double dot 40. Using the YZ relationship, A double dot 40 equals 1 minus big A40 over D. And we get the approximation 10.085. And then A double dot 60, the annuity due, payable every 6 months. Again, A double dot 60 applies the YZ relationship. We get the approximation 4.1136. And we can get 20E40. We are given 20P40. And then upon calculation, we get 9.6425. This is for the corresponding annuity due. We need to get the present value for the annuity immediate. Applies the relationship between the annuity due and annuity immediate. with m equals 2. The first term we already calculated, 9.6424. And then the very last term, we get new 20, 20p40. Upon calculation, we get the final answer for this, 9.1963. That's it for today's video. Thank you for watching and see you in the next video.